honored fine art students. Some of you see an email to get a free ticket, stop and I'll pick those up. All three buy additional tickets for $5 if you need. And on our side, you meet today during lunch with lectures. Members are required to attend, and you are required to bring your service hour home. West River Health Science Center offering 4 summer camps to learn about nursing and healthcare. If you're interested in that, please, there's a poster hanging in the hallway by the surveillance room. Also, you stop in to the guidance office to discuss. Congratulations to Liam Caribou and Lars Knudsen, both selected for the South Dakota Senior Honor Choir. Congratulations to both. All please stand for the to the flag.
Into the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Oh, have a good day.
I need Another one bites the dust. Remember, it's not enough to just type stuff in your calculator. Make sure you write out what you're typing. That's actually how I grade these when it comes time for quiz. One for the work, one for the answer. One for the work, one for the answer. One for the answer, because that one you just subtract. Make sure you got decimals with them, otherwise it's going to be beyond dumb. 21.8, 24.3. Who's still rolling? All right. For law of sines, I need a control pair. In this case, rut-row raggy, I got angle, side, side, and it's acute angle. So we got potential trouble headed our way. I'm going to start with, I do have a control pair. I will use that control pair in 21.8 to go find the measure of angle C. It's going to be the arc sine of. Now the form is always B sine of A over A if you do it that way. 21.8 sine of 24.3 over 19. Head to my calculatron. Quit. Okay. Second sine, I don't remember things. 21.8 sine of 24.3. Close it. 19 over whomp. Doot doot and doot doot. So I did my law of sines off of an acute angle side side, and I end up with an acute angle. What does that mean? Okay, there were two possible triangles. So triangle number 2, I'm going to toss over here. A was 24.3, across from it was 19, next to it was 21.8. C was this one that I just found. B was up here. Okay. I always draw mine in that orientation because then it's just fill in the box, fill in the pattern. So if I got that this one was 28.175, confirm. Okay? Because I see enough scrunched eyebrows to say either this went horribly wrong or we don't know what he's doing. We got that? Okay. Remember that if I get this one as 28.175, then that means 180 minus that thing was my other possibility. So this one could have been 151.825. Now solve both triangles. Okay. If I'm looking at this one, well, I just got two of the angles. How about 180 minus that 28 and change plus my original 24.3? And I get my remaining angle, 127.525. Over here, I'm going to do the same thing, 24.3, 151 and change. So 180 minus the group, 24.3 plus 151 and change, close the parentheses, womp-a-domp, and itty-bitty living space. That one is not very big at all. 3.875 degrees. Now, I have to do another round of law of sines to find length AC on both of them. To find it in this guy, again, I got my control pair, and now I got an angle across from it. So I'll say AC, or little b, is, where'd it go, 19 sine of 127.525 over sine of 24.3. And again, I'm going to use the calculator to get as accurate as possible. See that 127 and change? I can highlight it, or I could go up here, hit enter on the calculation so it's my latest answer. If it's my latest answer, I can use the answer button. You got choices. 19 sine of stuff over sine of 24.3. $36 and change. Likewise, I'm going to do one down here. Except this time it's little b is 19 sine of itty bitty over sine of 24.3. Whoop. 19 sine of that, where'd you go? There you are. Itty bitty over sine 24.3. Another itty bitty. 3.1198. Ew. Guess we're going to have to say it's about 3.12. Now, if your decimals down in the thousandths place are off, that's okay. Remember, we're going to use those decimals to 3 places because it's going to keep us pretty accurate. As long as you're going to 3 places, you should be mostly good. I could see that 36.617 going as far as like 36.622. Like, it can wiggle a little bit. That's still only 5/1000ths off. All right. But if you're going to 3 places, if you're using the highlight feature, if you're using the answer feature of your calculator, you should be pretty close to these. So, we start with, did you get the first angle? I'm just flat out going to say, did you get the second angle, which gets the second triangle at all? And then in them, these subtract from 180 to find missing angles. I'm going to say together those are 1 point. Okay, this and this. And then 1 each for finding your missing sides, because those were another round of law of sines. Okay? So find the angle, start the ball rolling. Did you recognize there's another triangle? Did you subtract from 180 to find your missing angles? And then did you find the side, find the side? If you did not do this, you wouldn't have had this triangle at all, which means I'm going to say, yeah, instead of domino effect 4 out of 5, now you got your 3 out of 5, because that was kind of the whole point of yesterday. We took the entire day for a single example. Okay? So if you did not get that 151 and change, if you did not get your second angle, did not get your second triangle, then you deserve the 2 off, because that was the whole point of yesterday. In which case, you should probably be asking questions. No. Oh, no. We're going to erase it this time. Yesterday I didn't. And had to make up a problem really fast on the fly for second hour. Anything from the homie work? I think it was 2 of these double triangle ones, and the others were the no triangle, right triangle, like easier cases. How do you feel about the double triangle ones? Like, if you follow the format, right? If you set it up as a template and this goes here, then this goes here, then that goes there, it's almost like color by number except for math, right? So it's an algorithm, it's a process. If we have problems with the process, then that means we need more practice and ask questions. Number 1 thing you should do at the very beginning, before you do anything else, is what, Caden? What should you do before anything else?
See if, like on the triangles?
Before you start any of these problems.
Look and see if that's an angle. Oh, yeah, put in degrees.
As I walk around, God, what do I get? You got the same. Oh, well, that's dumb. Make sure you're in the right mode, okay? If they're giving you information in degrees, you better be in degrees. And every time you reset the calculator, every time you pick up a new calculator, it's not the one you were using yesterday. What happens if it was the one you were using yesterday, but someone else used it second hour? Someone else came and borrowed it for a chemistry test, and they reset it. Okay? Always double check that. All right. So everything we've done so far, law of sines is based off of if I start with angle, angle, side, angle, or angle, side, side. Law of cosines is for the remaining 2 cases. Side, angle, side, or side, side, side. Remember, there were 4 or 5 different congruence theorems with geometry. And they're all depending on what information you're given. In every one of these cases, I'm giving 3 pieces of information. You cannot solve a triangle where they give you 2. You have 3 pieces every single time. Think back to our right triangle stuff. Well, no, they always gave me 2. They just gave me one side and one angle. But it was a right triangle, so we knew it was 90 degrees. That was 3 pieces. Okay, so it all depends on what we're given. Law of cosines, what's real funny for it is how we derive it is different at the pre-calc level than it is everywhere else in math. Because everywhere else in math, they use a trig identity to simplify the problem. And I actually had to rack my brain a little bit this morning to remember, wait, how do you do it without that identity? It's like the basic identity. We all know I squared is -1, right? It's just common knowledge from algebra 2 onward. Well, sine squared of theta plus cosine of squared of theta equals 1 is the same basic identity for all of trig. We don't know that yet. So how do we get a law of cosines if we don't have that? Just like before, I'm going to throw in an altitude. I'll say it's h. And b, covering the entire base, doesn't do me much good in this case, because when I'm dealing with cosines, I want the adjacent. The adjacent is just from here to here. I don't want all of b. I want just this spot. What could I call this spot? Do I know that it's half of b? What if it's 49% of b? What about just x? Okay, let's go all the way back to algebra half. If the whole thing is b and x of it is over here, how much is right here? B minus x. Okay. Now, the way that this is done to derive law of cosines is I'm going to Pythagorean both sides. I'm going to say in this triangle, on the one on the left, if I want to know what h is, can you tell me that by Pythagorean, algebraically? Who gets squared? Do I add them or subtract them? Okay. I'm trying to find a leg. Remember, leg is square root of hypotenuse minus leg, both squared. So I can say that h on this side is square root of c squared minus x squared. What about from the other side? It's going to be a little bit uglier. A squared minus b minus x squared. But the good part about it is if h equals stuff and h equals stuff, stuff equals stuff, right? That means I don't have to worry too much about like factoring and all that kind of business, because if I have square root of thing equals square root of thing, what can I do to both sides? I can square both sides. Getting c minus x squared is a squared minus, I will expand this one out, b squared minus 2bx plus x squared.
Why wouldn't it be c squared minus x?
Oh, because I just plain forgot to write the squared. I said it, but I didn't do it. How dare I? And yes, I did put that one up there from the other day for anyone who's going to get crabby about it. All right. Think about it. What can I do? What the hell? Denied. Marker says no. Marker vetoed. I got the other one over here. We'll do that later. How about a disturbance? C squared minus x squared is a squared minus b squared plus 2bx minus x squared. Okay, we're getting there. Things are starting to, there's no parentheses anymore. There's no radicals anymore. I'm getting towards a formula. What if I tried to add x squared to both sides? We're getting there. Well, A, B, and C are all sides on my triangle. I see what they are. I've got numbers right there. I can use those. But X is this temporary thing that we put in. And that's why it becomes the law of cosines. Because back in this triangle, off to the side, I can say the cosine of A is x over c. Cross multiply, x is c cosine of A. That's why it's the law of cosines. Everything you were doing so far was just Pythagorean theorem. Pythagorean theorem and rearrange. Do algebra stuff. What turns it into a formula is the definition of cosine allows me to replace that guy with c cosine of A. And then I rearrange the whole works to get A by itself, because that's usually the thing we're dealing with in our formula. A squared is B squared plus C squared minus 2BC cosine of A. Okay. The law of cosines is Pythagorean theorem plus definition of cosine. What it allows me to do is now I can solve any triangle. Any triangle I am ever given with 3 pieces of information, whatever they are, I can now solve them. Because I have all the possibilities covered of angle, side, angle, angle, side, angle, side, side. Now this will take care of side, angle, side, and triple side. What I can't do is triple angle, because then there's no side lengths to compare them to. That's where we got similarity instead, where they'd have the same angles, but one was just way bigger than the other. Okay? So this formula, they give it to you 3 different ways. It is not necessary. You see how they gave this to you 3 different ways. I don't need 3 different formulas. All I need to know is this, and A is pair A is the pair you're trying to find. What is B and C doesn't matter. Which is B, which is C doesn't matter in the formula, because B squared plus C squared, what if I swap those? Addition is commutative. Doesn't matter. B times C. Well, 3 times 5 is 5 times 3. If I swap them around, it doesn't matter. So all you got to know is that A is the pair you're trying to find. So I think of it more like side is leg squared plus leg squared minus 2 It's more like that, where B and C are the two legs on either side of the angle you're talking about. It doesn't matter which is which. Okay, but it is just a formula, and it is just formula plug and chug. So if it's a formula plug and chug, well, let's get some numbers to plug in. Hockey player attempts a shot, 20 feet from the left goal post, 24 feet from the right goal post. If the regulation goal is 6 feet wide, what is the shot angle? And that will not do. That will not do. If we're talking about hockey. A. Angle A. It's hockey there, A. Don't you know? I was raised in northeast North Dakota, don't you know? Everyone thinks we're all practically Canadian there, hey. Do you know until a reduction in nuclear armament about 10 years ago, 12 years ago, if North Dakota would have seceded, it would have been the third most powerful nuclear nation in the world? Turns out when you put all of your nukes in the center of the continent, they're fairly safe. But all I care about here is that I've got a triangle with a side length, 6, 20, 24, and I'm looking for angle A. There's my angle A. So that's the thing I'm trying to find. The letters, the names of the vertices don't matter. What I'm going to call is my angle that I'm talking about, or my side that I'm talking about. Not really a control pair, but that's my A and angle A, regardless of what the vertices are, because that's what I'm trying to find. So I go to my formula. A squared is b squared plus c squared minus 2bc cosine of A. And I plug in what I know. What do I know? Okay, I know 6 squared is, and remember, it doesn't actually matter what b and c are. Now, I know they're actually b and c in the problem, but it doesn't matter because I'm going to add them and multiply them, and that's commutative. So times 24 times 20 times cosine of A. Solve! Please tell me after all this time you know what 24 squared is. Boo! Can't you do the mental math part on it? 20 plus 4, 20 plus 4. Can you FOIL that? 400 plus 80 plus 80 plus 16? 576. Boo! All right. Minus 480 by 2 is 960 cosine of A. 36 is 976 minus 960 cosine of A. And for some reason, I get kids all the way in PreCalc who will now try to freshman that. And I will have kids year after year try to tell me this.
It's just quick and easy.
No! Yo, this is no different than 36 is 976 minus 960x.
Yeah, I don't see it, bro. Slide the X over.
Okay, so please do not do the dumb Subtract 976. Divide by the negative 960. Cancel, divide by 2, 45, 47, 46. It is a fraction. Well, 94 over 96, divide by 45, 46, 47, 47 48ths. Y'all, we just said the cosine of A was this. Now you need to do the arc cosine of this to get the actual angle. Arc cosine of. So what is the angle, eh? 148.
I got like 11.
Yeah, I got 11.7158.
So with arc cosine, it's not where we flip it.
No. Remember, when the -1 is on the name of the function, it means inverse. When it's on a value, that's reciprocal. And that has bothered me since 1996. 11 point something? Okay. Now, after doing it the long way, what if I said, yo, this is a calculator shortcut and it's one of my favorite parts of trig? Let's womp. Before I go plugging things in, y'all know algebra. Can you get angle A by itself in the formula? Do it. Rearrange the formula. Get angle A by itself. You've all done formula work. You've been working with literal equations since algebra half. What's up?
Do you know how they named?
They started picking letters. Here's a C, eh? Here's an N, eh? Here's a D, eh?
One of my dad's.
Yeah.
The funny thing is, like, of all the Canadians I've met, they don't really have like accent, but it's all North codes. I mean, I know some accent from like.
Because it's more of a Norwegian colonialism thing. Yeah.
Like I know that like some Canadians sound it, but like it's mostly
Yep.
what I've heard is mostly
The northeast portion, east coast of Canada, they got the bad Canadian accent. No. Because both were colonized by Norwegians. All right. I'm going to have to subtract both of those. I'm going to have to divide by that stuff. I should not be talking over 13 different people. If I got to divide by that stuff, and if that altogether equals cosine of A, a calculator shortcut for you. The measure of angle A is the arc cosine of A squared minus B squared minus C squared all over negative 2BC. Now, try that instead with this triangle, and you'll see why I think law of cosines is actually so much easier than law of sines. There's no ambiguous case. I can just arc cosine A squared minus B squared minus C squared I need a parenthesis in there. There we go. Divided by negative 2bc. Negative 2, b is 20, c is 24, or vice versa, doesn't matter. Close the parentheses to say I'm done with the denominator. Close the parentheses to say I'm done with the whole cosine. Womp. 11 and change. Or, a right view calculator is worth its weight in the proverbial gold. I can just type it as a squared minus b squared minus c squared over negative 2bc. Type it the way you write it. Okay? That calculator shortcut means law of cosines is just... What if that was... Uh-oh. I did an arc function. Arc functions are restricted. What if that wasn't actually 111? What if that was actually 168.3? But where's arc cosine restricted to? 1 and 2 instead of 1 and 4. The problem with the law of sines is that it's restricted to quadrants 1 and 4. There are angles that are in quadrant 2. There are obtuse angles. So when I did the law of sines, I had to be really careful to make sure that I didn't accidentally get the reference angle instead of the real angle. That's why we got 2 triangles yesterday. But law of cosines is in quadrants 1 and 2. Law of cosines covers all angles 0 to 180. Law of cosines will never give you an ambiguous case. Law of cosines works perfectly every time the first time. Just like when you first got into quadratics and you got the quadratic formula and you had to solve something, you're like, I don't want to factor that. You could just use the nuclear option, right? You could get the quadratic formula on something that was factorable, and it worked every time. You can do the law of cosines, and it will work every time, if you have the correct information. So in this case, we are going to find the angle. You know what? While we're here, what if I wanted to find the side length instead? Whee! That's it. If I want to find side A, it's just square root of all that junk. You get to calculator one-shot the law of cosines. Just make sure that you're actually writing what you're putting in the calculator. Okay? So, they want to know what is the angle formed by the 2 trails that lead to the camp. They want to know angle A. Go use your law of cosines, whether you use the full calculator shortcut or not, I don't care. Go find angle A. No, I want to see you do this problem. If we got time at the end, I'll bring up a video I saw just last night where one of the local reporters in Grand Forks County, North Dakota, a whopping 20 miles away from my home, and you'll hear what a true North Dakota accent sounds like. No, it hurt me.
That's all you do. You just find out one
Yep.
side and you go.
Ta-da! Well, since this is the thing I'm trying to find, I will call that my A in my formula. The other two, it doesn't matter what they are. I'm going to call this angle A, little b, little c, because it doesn't matter, again, addition, multiplication, or commutative. I get to just jam this into a formula. I'll say the measure of angle A is arc cosine of A squared minus B squared minus C squared all over negative 2BC. And I'll just jam in numbers. A, B, C, 1, 2, 1, 2. I jam it in a calculator and I'm good to go. Make sure you're in, could I get the angle in radians? Who says I need my angle in degrees? Angles can be in degrees or radians. Could I get some nasty decimal radians and then take that, divide it by pi to put it in terms of pi? Ew, yeah, we can. I'm not gonna. Okay, just keep it in degrees for this whole section. What'd you get? 46 point change? Cool. Womp womp. You look at it now, it's law of cosines, but it's got sass. So now, again, I don't care about A, B, and C in terms of their vertices. The A in my problem, or in my formula, is the control pair that I'm working with. So, since I'm trying to find little c, that'll take the A spot in my formula. You see why they gave you 3 different versions of the formula? Is that also completely redundant because I could have vertices H, J, and K instead? Yeah. So you just got to know that A is whatever you're working with, whatever you're trying to find. I'm trying to find a side length. I got a formula for that. Formula is the square root of b squared plus c squared minus 2bc cosine A. So in here goes 8 squared minus plus 5 squared minus 2 by 8 by 5 by cosine of angle 65. And I get a boot. How much? $7.42 who? Confirm? All right. Look at the directions though. It doesn't say just find that side. It says solve. So now that I have all 3 sides and 1 angle, I have a choice. I can go to the law of cosines to find angles A and B, right? I've got 3 sides, just like the hockey problem. Or I could go back to the law of sines because now I have a control pair. And it's your choice. It is actually your choice. So let's check that. If this is my control pair, I could say the measure of angle B is, by law of sines, it would be the arc sine of 8 sine of 65 over that answer. Or, now that I have this side length, I could do the measure of angle B is, by law of cosines, arc cosine of, now this would be my A, 8 squared minus 5 squared minus answer squared over negative 2 by 5 by answer. Both of those should come out the same because they're the same angle. I would like some of you to try it with the law of cosines, some of you to try it with the law of sines. Like you and your neighbor switch hit. Yep, I want one of you to do law of sines, I want one of you to do law of cosines. And let's make sure this actually works. So I should be able to do arc cosine of 8 squared minus 5 squared minus my answer squared over negative 2, 5, answer, womp. 77 change. Versus if I did the arc sine of 8 sine of 65 over, I can't say answer anymore. I have to, okay, I wanted to point this out. When you highlight something to enter it, I don't know why, this is just a failing of the TI series, they will not put it on denominators. Okay, they will not put it on denominators. I'll show you that again. If I'm right here and I say, okay, I'm going to go highlight this, it will not throw it on denominator. Okay? So just be aware of that. What I would do instead, I cheat and I say, oh, hey, go do this again. Because now that's my answer again. I just highlighted this and hit enter so it wouldn't be my most recent answer. And now I'll do arc sine of 8 sine of 65 over answer. I said over answer. There we go. Okay? So I'm just showing you that those both work. There are cases in which it will give you, say, a false positive. There are cases where if you do law of sines, it won't give you the right answer. When would doing the law of sines to find my next angle give me the wrong answer? Think about everything we did yesterday. No, the triangle is possible. When would doing arc sine of thing give me the wrong answer for the angle? Not negatives, because I can't have negative angles, but the other way. What if it's supposed to be an obtuse angle? I have a physical triangle in front of me, not two triangles possible. I have a triangle in front of me, and it's supposed to come out as 120 degrees, but I do the law of sines to find my missing angle, and it tells me 60. Because arc sine is restricted to quadrants 1 and 4. So be aware of that. There is a way to get around it. I want to see if you can figure it out, because I'm pretty sure it happens in this problem. Yes? Front row. Oh,
So something's wrong with my domain.
Oh, yeah, mine did the same thing for the cosine one.
why'd you square it?
That? I don't know. Answer squared.
Yeah, but it's supposed to be this squared minus this squared minus this squared, and you damned it in there twice.
Oh, I did.
Yeah.
Whoops.
So you're trying to take the arc cosine of something like 11 billion right now.
Okay.
So. Okay, draw an arbitrary triangle. It doesn't have to be accurate. If that helps you to find your missing information. What information do you have? Do you have enough information to start with the law of sines, or do you have to start with the law of cosines? Do you have a control pair, or are you finding a control pair? Okay, I'm just going to draw an arbitrary triangle. It might not be to scale. In fact, just looking at the numbers, I can tell you it's not going to be to scale. Because you don't have a control pair, you're trying to find a control pair. What do you have to start with? Law of sines or law of cosines? I don't have the control pair to start law of sines. I will start with the law of cosines. And if I'm trying to find a side length, well, that's just the square root of a bunch of stuff. So 7 squared, 10 squared minus 2 by 7 by 10 by cosine of 34. So, square root of all that stuff. 7 squared plus 10 squared minus 2 by 7 by 10 by cosine of 34. Double check. Yep. Okay. So I get one of them. Now you got a choice. Because you have a control pair, you are now allowed to go off to the law of sines. Because you have three sides, you are allowed to go to the law of cosines. Like those old choose your own adventure books, right? Do you get in the van or not? Go to page 63 or page 210. Don't get in the van. Okay? So, what do you want to find first, J or K? I'm going to find K. Because JK. No, there's a reason for it. I want to show you why this doesn't work. All right. Okay, I'll find J first. Fine. By law of sines, I would say measure of angle J is arcsine of 7 sine of 34 over that answer. Or measure of angle J is arc cosine of 7 squared minus 10 squared minus 5.739 squared over negative 2 by 10 by 5.739. I would like someone to try all 4 of these because it matters. Up here, if I found K first, measure of angle K, by law of sines, arcsine of 10 sine of 34 over that thing, or measure of angle K is arc cosine of 10 squared minus 7 squared minus 5.739 squared all over negative 2 by 7 by 5.739. Let's move you down here. There we go. Oh, screw you, Frank. Okay. I want someone should have all 4 of those numbers for me because something's going to happen. Okay? Blue, arc sine. What do you get? 43.063? 006. Okay. Green, angle J by law of cosines. What do you get? Is it? Okay. What is 34 plus 43? Why is there an eyeball rolling across my floor? Really? Because that looks like an eyeball. I find out Brooke's been an axe murderer this whole time. What about angle K by law of sines? Angle K by law of sines. Someone press the buttons.
Oh, wait, no. Whatever I gave you for angle J, no. Wait, but that's what I got. That's what I got. No, they're right.
What is angle K by law of sines?
77.00. That's really.
I did cosine and 102.9.
That's what I got on that.
Tell me why this ain't nothing but a heartbreak. Y'all, what's 180 minus 77 and change? What is 180 minus 77 and change? Which means those two angles, yellow and purple, they have the same reference angle. Which one's right, yellow or purple?
I'm going to bet that it is the opposite one based on no evidence at all.
All right, grab a calculator. What's 77.006 plus 43.006 plus 34? That does not add up to 180. 77 plus 77 ain't 180. 77 plus 77 plus 34, is that 180? It's close. Y'all, law of sines can only give you angles in first quadrant. What happens if the angle was actually supposed to be obtuse? It won't give you the obtuse angle, it will give you its reference angle in first quadrant. There's an easy fix to this. If you do law of sines for your second angle, find the smaller one first. Because if there's an obtuse angle in that triangle, and I find the small one, and then I find the small one, I can just subtract from 180 to find the big one. But how did I know, or how should I know, that angle K is the bigger angle, and I shouldn't do that one first by law of sines? Because across from it is a 10. I know angle K is going to be bigger than angle 10, or angle K is going to be bigger than angle J. What I would do if I'm switching over to the law of sines is always find the smaller one first, because the smaller one is guaranteed to be in first quadrant and law of sines won't screw it up. Y'all got that one kid on your team who all right, you can't throw the ball to them. You have to hand it to them. Because they're going to screw it up. Okay? You know that kid, right? Y'all, I was that kid. I couldn't catch anything to save my life. I got overwhelmed by stuff, but I could hit things really hard. Coach threw me at middle backer. He said, don't worry about coverage. Don't worry about anything. Kill something that comes in the box. Gotcha, coach. I got too overwhelmed by everything around me. But if I saw something coming at me, I would murder it. That's all I could do. Okay? If law of sines is gonna screw it up, don't let law of sines screw it up. Do the smaller angle first, or just do law of cosines. Okay? Because law of cosines will not lie. Law of cosines will always give you the correct angle because it covers quadrants 1 and 2. So,
So I got K for 77. J, I got 68.
because this gave you the reference angle instead of the correct angle, because law of sines only gives you quadrant 1 instead of quadrant 2, that means you domino affected this as an incorrect angle. But since this wasn't actually angle J, or K, this is not angle K. This is wrong because law of sines is only going to give you quadrant 1. If it's supposed to be 120, law of sines is like, nah, I don't do that. We don't do that here, okay? If you're going to do law of sines, do the smaller angle first. Or if you just go to law of cosines every time, law of cosines will, okay? If I know this one kid drops the ball every time, nah, I'm just going to give it to him. I'm going to give you a triangle and say solve. And who knows what information is there. So, let's try that again. Solve. Okay, you're just given information. Here's stuff. You got to figure it out. What? Well, yeah, because they're identities. You're composing a function with its inverse. Since law of sines has a tendency to screw things up, I would do two of those three. I would do law of cosines on two different angles and then subtract from 180. Law of cosines will give you obtuse angles. Now, speaking about patterns though, if I know that law of sines can screw up obtuse angles, and I have to start with the law of cosines, which of these three should I do first? I should find angle B first because it's across from 10. Angle B is going to be the biggest angle, and law of cosines doesn't lie about big angles. Law of cosines likes big angles, and it cannot lie. So, what do we got? B. Come on now, what's angle B? 111 and change. What's angle C?
27.661.
27 and change. I see bobbles. Angle A.
3.5.
40 and stuff. It's what you should have. Okay? Don't overthink it. Use the formulas. Use law of cosines to find the big angles, law of sines to find small angles. Because law of sines tends to screw stuff up. If I give the ball to Caden, I might as well just give it to the other team. So you make sure to do the thing you know is going to work. Okay? All right. The last two things are formula plug and chug as well. I won't go through the proof of either of them. They are how to find area. How do I normally find area of a triangle? Half the base times the height, right? Because a parallelogram, a quadrilateral is usually base times height, and I cut it in half to make a triangle. So, famous dead dudes come along, and they say, I can, okay, Heron's formula, Heron, Greek dude, right, he did a lot of stuff. If you go further in math, you're going to find a lot of his stuff in discrete mathematics. But basically, he did Pythagorean theorem kind of stuff, like we did to find the law of cosines. And he used it to substitute in for h and all that business. And it turns out I can get s. S is this side value you got to find. What is a plus b plus c? What's another word for that? Perimeter. If I take half the perimeter times how far each of those side lengths is away from half the perimeter, multiply it all together, square root, I get my area. Okay? It is just a formula, plug and chug. All right? It's just a formula. Find the perimeter, take half of that, that's your S value. S minus A, S minus B, S minus C, square root. Okay? That's if I'm given triple sides. If I'm given SAS, then area by law of sines, again using the law of sines to find my missing height, I can replace and get 1/2 BC sine of A. Now they give you all the different versions of it, but you notice BC sine of A. Side angle side. So it doesn't actually matter what the letters are. If I just have a triangle and they give me this is 30, 15, 10, then I would say 1/2 BC side sine of the angle sandwiched in between them. Okay? So they're just formula plug and chug. Different ways to find area once you use law of sines and cosines to start substituting in for that height. So, Heron's formula. First things first, you got to find half the perimeter. That's your S value. So S is, add them all up, 96, 126, 134. Divided by 2 is, nice. No, it's 67. Not so nice. Okay. And then if I have that, my area is simply square root of 67 times 67 away from the first one, 67 away from second one, 67 away from third one. Now, I can choose to find all of these values and simplify it. Or I can jam it in my calculator just like that. It doesn't matter. The area is about some decimal. Because it is going to be an irrational number. It's going to have a square root in it, so unless you can simplify the radical. Yeah, 67 by 29 by 16 by 22. That's a big number. I don't want to. I could simplify the radical. I don't want to. So about how much? Jam it in your calculator. Just make sure we're all getting the same thing. 827 change? Okay. So it's just formula plug and chug. I don't see a need to do both of them. Let's go 7b. Show me that you can formula. One 42, 10, 219. Right? 140, 210, 219. I'll tell you what, when you get that that perimeter too, I would just use the answer button. I don't want to type. Square root of answer times answer minus 61 times answer minus 70 times answer minus 88. I don't want to keep typing extra buttons. About how much? Okay. So that's one formula. Here's the next. Sir, reporting high levels of SAS. If you were given side angle side, whatever is in the middle is considered your A, and whatever's to the side of them is your B and C in your formula. So if my area is 1/2 BC sine of A, then my area is 1/2 BC 77 sine of A. So 70 to 35 sine of 108, which is a boot 30 and change? 33 and change? Okay. So as long as you know what that middle is, it is just formula plug and chug. So, and just in case someone decided to go to B because they thought I would go to B again, let's do A. Yeah, let's do A. A. I heard 33 and change. So 1/2 10, 250, 250, sine 30, a little bit under half. Seems like 120-ish. Don't estimate. Estimating's bad. 105 and something? Okay. Y'all, I'm going to rub a little salt in the wound. If you remember back at the beginning of section 4.1, when we got to our big systems problems, this is your quiz. Well, some of your quizzes. A couple of you did a different one. I had asked, do you remember law of sines? Because it makes this go 10 times faster. Okay. Remember they were all problems like this? Okay. He's going to step back 100 meters, so here's 100. Do you remember 25 degree and 29 degree angle of elevation? Which one's closer? Always the bigger one closer because you have to look further up. This is a linear pair. So what does this angle have to be? This is 161. I've got two angles. Can I find the other one? Are you sure that's 161? I'm going to say because that's too big. So that's 176, so this is 4. Y'all, law of sines. I've got a control pair to go find this. This is now 4 sine of 25 over 100. And now to find this, I do sine. Sine of 29 is x over that.
Is that a brownie point since you didn't label it yard square on the lunch bubble?
Ow. Okay, you know what? It'll be a brownie point if I get to take that one off on your tests. If you forget your yards squared on your problem.
A new logical
No.
person could see that.
No. Okay. Law of sines made these much easier. Remember, tomorrow, we're doing our quiz tomorrow instead of Friday. Okay? Because 4.7 took us an extra day, I do not want to start chapter 6 until we have completed the quiz on this. So tomorrow, quiz on 4.6, 4.7.